Welcome to my YouTube channel known as Brother J. In this case, we have the question which is about probability problems. Here we have a box containing 3 red balls and 5 white balls. We are told that 2 balls are drawn randomly from the box without replacement. It means the first ball is drawn, then before the second ball is drawn, the first ball is put aside. That is the meaning without replacements. So we're told to find the probability that A, both are red, B, both are of the same color, C, the first is red and the second is white, and D, one is red and the other is white. In our case here, we are going to use the tree diagram methods to solve such kind of questions. So first of all, let's draw the tree diagram. The tree diagram. So in our case here, we have 2 types of balls. The first one is having red color, the second one is having white color. So let us use capital R to represent a ball with a red color. Red ball, and the capital W to represent white ball. So our tree diagram will be like this. So let us start here doing experiment. Which is about drawing balls, 2 balls from the box. In the case of first draw, we can either come up with the red ball or white ball. Provided that in the first draw, the red ball is drawn. Also, there is a chance that the second ball drawn also is red, or the second ball drawn is white. The same applies to here. If the first ball drawn is white, again, there is a chance that the second ball drawn is red, or the second ball drawn is white. So in our case here, we know we have 3 red balls and 5 white balls. So the total number of balls is 8. So the probability of drawing red ball equals to the number of red ball, which is 3, over the total number of balls. So once we are finding the probability of drawing red ball, the number of events equals to the number of red balls, because we know probability of an event equals to number of events over number of sample space. In case of drawing red balls, we know the number of event equals to number of red balls. The number of sample space equals to the total number of balls. In our case here, the number of red balls is 3. The total number of balls is 8. So the probability of drawing red ball is 3 over 8. The same applies the probability of drawing white ball in the first draw. This is equals to the total number of white ball in a box over total number of balls, which is the number of red balls plus the number of white balls. The total number of white balls in the box is 5 over total number of balls in the box, which is 8. This is the first draw. The first draw. In the second draw, so we are looking the probability of drawing the second ball having the red color. Bear in mind, in the first case here, we have taken one ball and the ball is not in the box, it is aside. So it means after drawing the first ball, here we are going to remain with 2 red balls. How do we get that 2? Is 3 minus the first ball that we have been drawn. Again, the total number of ball is not equal to 8 because already one ball is taken. So here we have the probability of drawing a second ball with red ball equals to the total number of red balls left in the box, which is 2, because we have already taken one ball, over the total number of balls left after we have drawn one ball, which is 7. That is 8 minus 1. Again here, let us see if the second ball drawn is white. Remember, in the first draw, we have taken one red ball. It means here, what is going to be affected is the total number of balls, but the number of white balls remains the same. In our box, we have 5 white balls, that is the number of events, over number of sample space, which is the total number of balls in the box. Remember, we have taken one ball here, which is red in the first draw. So here, we're going to remain with 7 balls. In this case here, we're going to use the same procedure that we have used when we are dealing with the upper part of our tree diagram. So in our case here, if the first ball drawn is white, again we have the chance that the second ball drawn is red. The probability of drawing red ball if the first ball drawn is white is equal to the total number of red ball, because here we have taken one white ball, so the number of red ball is not going to be affected. So we remain with 3 red balls over sample space. Our sample space here is 7 because the box is containing 8 balls, but one ball, which is white, is taken. So we remain with 7 balls. So the probability of drawing red ball, provided that the first ball drawn is white, is 3 over 7. So let us proceed with this case. If the first ball drawn is white, also there is a chance of drawing white ball in the first draw. So the chance or the probability of drawing white ball in the second draw equals to the total number of white balls left. Remember, we have taken white balls here in the first draw. We have 5 white balls, so 5 minus 1 will remain with 4 over number of sample space, which is the total number of balls left in the box after we have taken the white ball, which is 8 minus 1, we get 7. This is our tree diagram. Let us proceed. So, in our case here, we are told to find the probability that both balls are laid. The probability that both balls are laid. In our case here, tree diagrams, we find that we have laid here, we have laid white, in this pass we have white, red. So here we write white, red. In this pass we have white. So we are told to find the probability that both balls are red in color. That is ara. So this is very simple. Take the probability of first draw, that is drawing red ball, which is 3 over 8, which is 3 over 8 times the probability of drawing a second ball with red color, which is 2 over 7. So here we have 3 times 2 equals to 6. 8 times 7 equals to 56. Simplifying, we have 3 over 28. By 2, we get 3. By 2, we get 28. So the probability that both balls are having red color equals to 3 over 28. Then B, we are told to find the probability that both balls are of the same color. It means we are supposed to find the probability that either both balls are supposed to have red color, or both balls are supposed to have white color. So we are looking for RR or WW. In probability, this is the same as to write probability of both balls having red color plus probability of both balls having white color. In our case here, we have probability of having both balls with red color equals to 3 over 8 times 2 over 7, because here we have R. So we have 3/8 times 2/7 plus, again here we are looking at the probability of both balls having white color, which is this one. In the first draw here we have 5/8, the second draw we have 4/7. So we have 5/8 times 4/7. So we have 5/8 times 4/7. In our case here, 3 times 2 equals to 6/8 times 7, 56, plus 5 times 4 is 20/56. 6 plus 20, we get 26/56. Simplifying by 2, we get 13. By 2, we get 28. So the probability that both balls are of the same color is 13/28. Okay, that is B. Let us deal with C. Okay, in C here, we are told to find the probability that the first is red and the second is white. So we are going to use the same tree diagram. The first ball is supposed to be red and the second ball is supposed to be white, which is this one, red, white. So to reach here, from here, we have 3/8, then here we have 5/7. So the probability that the first is red, the probability that the first ball is red and the second ball is white. This is equals to 3/8 times 5/7. Is where, through this pass is where we reach here, red, white. So 3/8 times 5/7. This is equals to 3/8 times 5/7. This is equals to 15/56. So the probability that the first is red and the second is white is 15/56. Okay, let us finish with part D. In part D, we are told to find the probability that one is red and the other is white. That is, it can be red, white, or white, red. The first can be white, the second can be red. The first can be red, the second can be white. It means red, white, or white, red, which is equals to probability of red white plus probability of white, red. Using our tree diagram here, the probability of red, white, it means 3/8 times 5/7. And white lead is this one, 5/8 times 3/7. So we have the probability of red, white, 3/8 times 5/7 plus 5/8, which is the probability of white ball, times 3/7, which is the probability of red ball. Okay, here we have 3 times 5, we get 15. 8 times 7, this is equal to 56. Plus 5 times 3, we get 15. 8 times 7, we get 56. This is the same as to write, we know 15 plus 15 equals to 30 over 56. Doing cancellation, we get 15 over 28. Therefore, the probability that one is red and the other is white is 15 over 28. Please don't forget to like, share, and comments. Thank you.